Hello, 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 and welcome back. In this video, we're talking about some algebraic properties of the cross product, as well as how the cross product interacts with our unit coordinate vectors. And then we'll take that and leverage this into determining sort of analytically a nice formula for the cross product where we don't have to think too hard. We can just sort of plug things in. So we start with a simple question about the cross product. How does U cross V compare to V cross U? So that is, if I take, let's call this one U, and let's call this one V. Compare U cross V and V cross U. Now these are both in the plane that is parallel to your computer screen, and so we know that U cross V or even V cross U is going to be perpendicular to both of these, so that is, it's going to go either in or out of the screen. So the question is, does it go in or out? We know the magnitude is the area of this parallelogram that's formed. The area of this is the magnitude, but does it go in or out? So again, use the right-hand rule. Literally, take your right hand and do this. I do this every time I compute a cross product like this. I use my right hand. You gotta. You point your fingers along U, curl them towards V. That's U cross V. That's the direction of U cross V, is the direction of your thumb, which is pointing inward. So here, U cross V is, so I'll say direction of U cross V is into the screen. Magnitude is the area of this. So what about V cross U? So do this in the other direction. Point your fingers in the direction of V and then curl them in the direction of U. So I'm sort of pointing my fingers downward with V, and then I need to curl them up to go in the direction of U. So my palm has to be facing up here, relative to the computer screen, and when I curl them in the direction of U, my thumb points out of the screen. So that is direction of V cross U is out of the screen. But again, the magnitude is the area of this parallelogram, which hasn't changed whether I did U cross V and V cross U. So two big things to point out here. How does U cross V compare to V cross U? Well, one, in comparing their magnitudes, U cross V is exactly the same as V cross U in magnitude. However, they have opposite directions. So U cross V has opposite direction as V cross U. And so if the magnitudes are the same and they have opposite directions, what that tells us then is U cross V, this vector, is the negative of V cross U. Or rather that negative U cross V is negative, or it is V cross U. They're opposites of each other in the vector sense of being in opposite directions. So parallel to each other, but opposite directions. So this is very cool. There are some other nice properties with the cross product. We have to keep in mind here, though, because of this thing we've just noticed, this is called anti-commutative. This is called an anti-commutative property. Right? Commutative property tells us that 3 times 4 is the same as 4 times 3. In cross product operation, these things are anti-commutative. U cross V is negative V cross U. When we switch the order, we get the negative. And that's pretty cool. Have you seen any other operations that are anti-commutative like this? Perhaps not. This might be your first encounter with anti-commutative operations. And these are very neat. So what else do I want to say here? They're anti-commutative. So that means order is very important. The order in which you write a cross product is very important. So when it comes to other algebraic properties, like the two distributive properties that we get, so that is, how does a cross product distribute over a sum? It distributes like you think it would, right? U cross V plus W is going to be U cross V plus U cross W. And it is. But you have to keep the order in mind. So notice U is to the left of V and to the left of W. And it stays that way. U is to the left of V and U is to the left of W. When it distributes, it has to stay that way. So that means if I flip this thing around and I go U plus V cross W, it's going to distribute how you think it would. It's going to come over here to the V and it's going to come over here to the U, but it's going to come over to the right side of them. U cross W plus V cross W. So that's the deal. So you really got to be careful with your order of the cross products and how that interacts with the distributive properties like this. The other property here is the associative one. That is, if I scale U and I scale V and then I take their cross product, well, really I can just reserve that scaling to the end. I can compute U cross V just itself and then scale that area by the product of the two scalars here. So that's the associative property of this. So here's some nice algebraic properties of the cross product. And I mentioned that I'm going to leverage this into obtaining a nice formula for the cross product. How do we actually compute it? Besides just, doing magnitude U times magnitude V times the sine of the angle between them. Remember, angle between two vectors is in general hard to get, so I'd like to have a expression for U cross V that does not involve having to find the angle between the two vectors, because we know we've done that. That's a pretty sort of arduous, tedious process to find that, and a lot of formulas to remember if not. So let's see how we can leverage this. Well, we're going to do this by first seeing how they interact with our unit coordinate vectors. Remember I, j, and k. This is our x-axis, or sorry, this is usually our y-axis. This is our x-axis. This is our z-axis, coordinate axes. Remember that I'll use red for u here, that I is 1 in the direction of the positive x-axis, so that's a 1. This is I. J, I'll use blue for J. Also length of 1, but now along the y-axis. I should have done a little hat for I. And then and then K, I'll use green for this. This is 1 in the direction of the positive z-axis. And we can ask ourselves, well, what are the cross products of various combinations? Pick any two of these. What is the cross product of them? And we want in both orders because we know order matters with the cross product. So this is a good time to get comfortable with the right-hand rule. I advise you to stop the video here and work through these, figure out what these are before I just tell you what they are, see if you get the right answer as I go through this, and if not, you can sort of correct your thinking and learn something. So let's do I cross j. Remember that these unit vectors, so I, j, and k, these all have the same magnitude and they're 1, and so when we do the cross product of any two of these, the magnitude will be 1 because they're also orthogonal to each other. So each of these is orthogonal to each other, so when we compute, remember that the magnitude of U cross V is magnitude U times magnitude V times sine of the angle between them. For any two of these, theta is pi over 2, or 90 degrees. So sine of theta is 1, right? These are all perpendicular to each other. We talked about this when they're perpendicular. We just get a rectangle. And so in any of these cases, this U cross V will just be 1. I'm not going to write there because it's not true in general, but in this case it's 1. So what we're really concerned about here is the direction of them. So I cross J. Point your fingers along I. Imagine you're inside of this plane, inside of this space here. Point your fingers across I, curl them in the direction of J. So our thumb would then be pointing up and have a magnitude of 1. Be pointing directly up, that means it'd be parallel to K, and it has a magnitude of 1. So that means it is K. So I cross J is K. Okay, what about J cross K? Again, pause the video here, work it out yourself. I really want you to do that. Try and work it out yourself. If you haven't paused yet, do so. If not, I won't mention it again. I'm sorry. I'll point my fingers in the direction of J, curl them in the direction of K. I am now going along the x-axis. I have a magnitude of 1, and so that means I am I. Let's see, k cross I, fingers pointing up, curl them towards I. I'm going in the direction of j with a magnitude of 1. What about I cross I? Well, I can't really do the right-hand rule, because which direction do I curl them? I curl them in the same direction that I'm pointing my fingers. When that happens, you know this gives the 0 vector. When the right-hand rule sort of doesn't turn out a direction, when it's impossible to use it, that means we're dealing with the 0 vector. Another way to think of this, remember we talked about if the two vectors are parallel, then the parallelogram formed between them has no area, and so the magnitude would be 0, and so we must be dealing with the 0 vector. Same thing for j cross j. These are parallel to each other, so it's the 0 vector, and same thing for k cross k. And so that's sort of all the combinations, but remember we have different orders. So if I do instead j cross I, one, you can sort of work that out yourself. Point in the direction of j, your fingers in the direction of j, curl them towards I, so that means my palm is sort of facing towards me. The thumb goes down, and I get negative k. And that tracks with what I mentioned before, the anti-commutative property. I cross j is k, j cross I is negative k. Same thing down here. If I do k cross j, I get minus I. And let's see, I cross k is minus j. So one way to think about this, if I lay out I, j, and k, this is sort of a mnemonic to help remember this. How does this work? Well, if I take, say, I cross j in the direction of the arrows, what I get is I just follow the curve and I get k. And if I do j cross k, I end up with I. And if I do k cross I, following the arrows, I end up with j. If I go in the opposite direction, if I did I cross k, I would end up with negative j rather than j. So that's one way to do this, is with this sort of circular thing. All right, so I told you we're going to leverage this to find another form of the cross product. We'll do this in an example in the next video. So I'm trying to keep these videos to a reasonable length. So I'm going to end the video here. In the next video, I'm going to work through this example, but I'll give you a chance to do it first. See you there.